Everyone in here is ready to go, right? Yeah. It's Monday. Okay, all right, let's try this. So, class. Faye.
Yeah.
Thank you. Yeah. Only Faye is paying attention. For those people watching online, Faye is the only one responding. Okay, anyway. Alright, so we're now going to find bounds on integrals. Functions continuous on a closed interval from a to b, then lowercase m, which refers to the absolute minimum, and capital M denotes as the absolute maximum, absolute min, absolute max. These are important because you're going to see these notations coming up, and they'll probably kick you in the face because if you're not understanding what that means. All right, respectively of f on interval from a to b, then you're going to have this side is going to be less than this side, and somewhere in between you're going to have the average value is between the minimum and the maximum of the bounds. Okay. All right, find the upper bounds, lower bounds, the area A under the graph of sine x from 0 to pi. So, if I take let's say we graph this, 0.
Pardon the interruption, staff and students. Students, if you signed up for the ASVAB test, please report to room 934 at this time. Once again, students, if you have signed up for the ASVAB test, please report to 934 at this time.
All right, so there's a graph of my sine x from 0 to pi. It's a good graph, right? Beauty, eh? Now, we want to find the area under the curve. So area under the curve is I'm going to integrate from 0 to pi of sine x dx. So integration of sine gives me, since I only have Faye participating here, Faye, what is integration of sine?
Oh, is that what it's gonna be written backwards?
Yeah.
Negative cos.
Very good, see? Negative cosine x from 0 to pi. All right, so let's evaluate. So upper bound is going to be pi. What is cosine at pi? -1, very good. So I have negative on the outside, and it's -1, right? Minus the lower bound. My lower bound is going to be over here. What is cosine at 0? 1. Now it's going to be -1 because that minus on the outside. So right here, two negatives will make a positive, two negatives will make a positive. So altogether, my total area under the curve is going to be 2 units squared. Putting units square is important, especially if it specifically is asking for the area. Okay, so now let's look at my graph. Right here, find the upper bound and the lower bound for this. Upper bound, that means it's going to be the highest point here. That's going to be where? My upper bound is 1 at, is going to be, my location is pi over 2 comma 1. My lower bound, actually I have two lowers, which is going to be here and here, which is going to be at 0 comma 0 and pi good, Faye? You're not zoning out at all, right? Okay. Usually you do more writing while we're going over this.
Yeah, I have this one already.
You what?
I have that.
Okay,
already.
just making sure. Double checking since you're the only one paying along with this. Alright, so right here, mean value theorem. So what it is mean value is the area under the curve from here is going to be all this right here equal to it's going to be equal to this area here. You notice there's a little bit under here and a little bit of an overestimation here. So the integration is going to be equal to some u value, my f of u, times b minus a. So it's basically when we're doing the Riemann sum, remember when we're doing the rectangles? So b minus a is going to be the distance from here to here, where the distance from here up to this point on my function is going to be my f of u. So I'm going to have a rectangle here where it's going to be equal to f of u times b minus a. Is going to be equal to my actual integration of the whole thing. So my whole point is, usually on this, is trying to find where this is actually going to apply. Does that make sense? Kind of. Alright, mean value theorem on integrals. For a function is continuous to close interval a to b, there is a number u. Anyway. From a to b, u is somewhere in between those two, for which that this actually works. So the rectangles I just made is going to break up into being same thing as this. So that's what it's still saying. So the rectangle, and this is the area under the curve. They're equal at some place, and some value of u. Yes, no, maybe? Okay, here, let's apply this then. We want to find u, guaranteed by the mean value theorem, for this integral from 2 to 6 x squared dx. And supposedly, this should be equal to f of u times 6 minus 2. Alright, so let's go ahead and start with the integration part, and then we'll work with the other part here in a second. So integration part should be, I'm going to take the integration of x squared, which is going to give me x cubed over 3 from 2 to 6. Apologize, that is a 3. There you go. So that right there should give me, what's that, 216 over 3 minus my lower bound, which is going to be 8 over 3, which should give me 208 over 3. So this is all my integration side. Okay, now, it's got to be equal to this over here, so I'm going to have 4 from there, and it's gonna be times f of u. So f of some value, I don't know what the x value is gonna be yet, or in this case, the u is gonna be somewhere, let me get my graph, the u is gonna be somewhere here. So it's f of some value, so I'm gonna have the function right here. So this is going to be for, my function is x squared, is equal to 208 over 3. And divide everything by 3, or I'm sorry, 4. So that's 52 over 3 is equal to x squared. And let's take it up here. So that's going to be there we go. Okay, recopied it. Square root. So plus or minus the square root of 52 over 3 is equal to x. And my integral has to be between 2 and 6. Has to be between 2 and 6. And I don't know my radicals that good, so let's see what the calculator says here. And for the sake of argument, do you think the negative's gonna work? Why would the negative not work? Because it's negative, it's outside of between my 2 and 6, right? So, let's see. Square root of 53 over 3. Ah, dang it, come on now. Control, enter, there we go. 4.203. So, what does that represent now? What does that represent? Soldier boy. Huh? What's it represent? You. It represents you, right? See what I did there? Soldier boy. You! You know, I'm actually trying here. Come on now. Okay, so what that really means now is, if I go back to the graph, like I was saying, my u value, in this case, the u value should be between 2 and 6. My u value is 4.203, right? And so that means that this right here, going from here to here, we had that value, and that this value right here, the height is going to be f of 4.203. So the area, which is going to be from here to here, f of this times 4, should be equal to my area, my total area, which came out to be where'd I get? 208 over 3. Let's see what 208 over 3 is. So 69.333, and let's try that, the area. So we said it was 4 times, let's go parentheses, and it's 4.203 close square, right? Because it was times f squared. Okay, x squared, there we go. So, pretty close. Because why is it off? Why is this not exactly the same?
Because of the square root of fitting 0 to
Did I make a mistake? Oh my goodness. Oh, you're right. Why didn't you catch me on that one earlier? You just like to watch me mess up. So 4.163. Nephi likes making me look bad. And let's see what, if we go back to it again, and there we go. Almost exactly the same now. So,
Hand sanitizer smells yeasty.
okay. Now, to go along with that, why would it not be exactly the same? Anyone have a guess? Yeah, the rounding. We actually did rounding twice. We had it on the square root where we rounded this one off. And then when we plug it back in, so when we plug that number back in, it's going to, 4 times this squared. We're gonna get an approximate answer there too. So yes, they're gonna not be exactly the same when I do these, because it should be the same, but if you ever approximate, it's always gonna be wrong. Alright, average value, right here. Average value of a function. This is important, especially if English is not your first language and you wanna yell at everyone, because oh, damn it, okay, wrong person. Get mad at everyone because English is not your first language, you don't understand what it's saying. So, average value of function, mean value theorem for integrals, okay, closed interval, blah, 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 right here, means that function f is also non-negative on the closed interval from A to B, area enclosed by the rectangle of the height f of u and the width of b minus a under the area of the graph from A to B, average value or mean value. So average value or mean value of f over A to B. So that's important to know that those are referring to the same thing. And then we're going to do another one, which is y bar here in a minute, which means the average value. So you're going to see the notation for this. Here it is. Average value of function, y bar. Average value, the symbol, bar, y bar of f over A to B is there. That's the average value. Yeah, they start making up all kinds of weird symbols later on. You'll get into like some analytical calculus geometry or something, and where you have the hat. So it's not bar, it's y hat, because it has a little over it, has a tilde. Find the average value of fx on x cubed on the closed interval from 0 to 2. Okay, 1 over b minus a. Like that. So I'm going to have 1/2 times integration, which is going to give me x 4 over 4 from 0 to 2, which is going to give me, what's that going to be? 4, 4, 16. 16 divided by 4 is 4. Yes. 4 is the upper bound. Subtract my lower bound. It's going to end up being 0. So I get 4 times 1/2 is 2. And that is going to be equal to my average value. So these type of problems, think of it like this. Let's say, for instance, you're driving from here to Douchebros. You're driving. And you average out 20 miles an hour. Did you do 20 miles an hour the whole way? No. You started at 0. You got faster as you tried to pull out in the intersection, right? And so you average out over your distance over time, because we do some faster, some slower on the curve, and it comes out that our average for this is going to be that. Christian, does that make better sense, or did you zone out?
No, I heard everything.
Okay. Just making sure. Eyes got a bit distance there. You're like pondering, like, did I leave the toaster on? Yeah, that was one of those looks. Alright, interpret integrals involving rectilinear motion. Net displacement is where am I at now compared to where I started. That's what that means. Net displacement is where am I at now. It says net displacement or sine distance of object whose motion begins at A, ends at B. Where am I at now? So, think of it like this. I'm walking from here to Douchebros and back. I just did it right now. Did you see it? Okay. What is my net displacement? 0. That's what that means. That is net displacement is, since I went forward going there and backwards coming back, so I have a negative velocity coming back. So my net displacement would be 0. Now, total distance has the absolute value here. So every single time I change direction, I need to account for that. So if it is half a mile to Douchebros, I walk forward to Douchebros, that's a positive distance, and I walk backwards from Douchebros, that's there's also a positive distance, right? So I have to add those together, even though I'm going a different direction. My velocity tells me my direction. If it's positive, going forward, negative, I'm coming back. So that's what that means. Alright, we're going to try this. So, object's rectilinear motion is moving along a horizontal line with velocity here, meters per minute. And this is probably one of the most used example and one that is in the AP exam. So, let's start with the first one. Find the net displacement from 0 to 6, interpret the results. So, from 0 to 6 of 3t squared minus 18t plus 15 dt. Take my integration, I get 3t cubed over 3 minus 18t squared over 2 plus 15t from 0 to 6. Since all these here have t's in it, so when I plug in the 0, it's all going to be 0, right? So I'm only focusing on mainly the top part. So let's do a little cleanup. 3 over 3 will cancel. This will give me a 9. And let's try this to make life a whole lot easier. So I'm gonna go to here, in my function, I'm gonna put that integration there. So my integration was x cubed minus 9x squared plus 15x. Is that correct? T cubed 9t squared plus 15t. There we go. Yes? Alright. I'm gonna hit enter. I get that there. Now, I'm gonna go right here, watch this. I'm gonna use the vars. So my function, I'm gonna plug in 6. There you go. So it's gonna evaluate for me and it does a lot faster. So a lot of these problems that you have access to the calculator, that is gonna be one of the things that's gonna save you a whole lot of effort and time. Just plug in your functions. So it's negative 18. Now, what does that mean? Christian, since you decided to volunteer by showing up late, okay, what do you think that means?
That's the total distance, like the block travel within that time period, 06.
No, we're not doing total distance here. We're doing net displacement. What I say net displacement does.
It's just the distance, not traveled, but displaced from like our original standpoint.
Where, okay, from the definition I gave you, where am I at now? That's what net displacement means. Where am I at now? Given that information, where am I at now?
-18.
Okay, now, where is negative 18 though?
Backwards.
Backwards, okay? In rectilinear motion, right is forward, left is backwards. So I am going left 18 units. That's where I ended up at. So did I only travel 18 units? Maybe, I don't know. But now let's do the next one, which is actually the total distance. And total distance is super important. I'm gonna take this first, 3. No, that's a minus, isn't it? Minus 18. Like that. Okay. Now, I need to take my velocity, that's important to understand. Your velocity, this is where your velocity is important. Okay? The reason why I keep saying velocity, because this is a velocity problem when I'm doing these. Velocity, factor it. I want to know when my velocity is equal to 0. Because when it's equal to 0, think about it. What happens when it's equal to 0? Is it changing direction? If it's going from positive to negative or negative to positive, it's going to change direction. That's important. So let's do, I'm going to say F that. So I F'd a 3 out of that. And let's F it some more. So I got some T's over here, right? Now, what are the factors of 5 that will add together to be negative 6? Negative 5, negative 1. Those multiply to be positive 5, add together to be negative 6. So using those right there, because I know I need to set these equal to 0. So here, T is going to equal to positive 5. T is going to equal to positive 1. Are those in my interval? Yes, they are. That's important. So those are in my interval. So now I need to change up my interval. So for my total displacement, I need to actually have a bunch of different integrals here. So my integral is going to be from 0 to 1 v of t absolute value dt plus integral 1 to 5 v of t absolute value dt plus my integral of 5 to 6 v of t absolute value dt. And that neat trick with the calculator comes back into play. Do we already have the integration of this? We already have the integration. The integration was, so my integration, let me change colors so I don't mix this up. There we go. So my integration is going to be s of t, because I'm going from velocity and I'm going up the chain, because normally in derivative I would go from velocity down to acceleration, where integration goes antiderivative goes up. So I got s of t is equal to my, what do we have, t cubed minus 9t squared plus 15t. Yes? Hopefully, yeah. Didn't I just put this in the calculator so I could actually help myself? Because I'm going to evaluate a lot of these problems. So let's evaluate here. Top minus bottom. So I'm going to say vars of 1 minus vars of 0. Positive 7. So my first value is positive 7. Next one, it's from 1 to 5. Vars of 5, my top minus bottom, always, top minus bottom, minus of 1, negative 32. So if that's negative 32, what does this right here do? Absolute value, so that's going to make it a positive 32. The negative 32 on that velocity is saying that I went backwards 32. All right, next one. Plus vars of 6 of 5 and positive 7 again. There we go. So my answer comes out to be, what's that, 39 plus 6, 46? And what was my units on this one anyway? Oh, meters per minute. So this is not units, this is in meters. So my total distance traveled is 46 meters. Where when we only did the net, that tells me where I'm at the end. So my end position is negative 18, but I walked a total distance of 46 meters. So they're both good to know. One, you know where you're at currently, and the other one is how far you walk to get there. Does that make sense? Yeah? Okay. Alright, everyone's going to make sure you like, share, and subscribe. We finished 5.4 today, so therefore it is due on Wednesday? Yes, Wednesday.